Good afternoon, everybody. My name is Fred Nauer. I'm the Chief Flight Instructor for Thunderbird Aviation. And today I'm going to be doing the FAA Safety Seminar about the IFR operations two-way radio communication failure, both from the standpoint of what the regulations say and then what you have to think about if this ever happens to you in the air. I hope it never does, knock on wood. So let's get started here. There we go. So IFR operations, two-way radio communications, the rules and the reality. And maybe a little bit of alternate reality near the end there. So the topics we're going to talk about today are both regulations. The first regulation has to do exactly with the topic that we're talking about today, 91.185, two-way IFR communication, two-way radio communication failure. We'll talk about what happens if you're VFR, what happens, then the last three things there, what happens if you're IFR. And then if we have time, we'll talk about Regulation 91.175, which is takeoff and landing in IFR situations, basically talking about what you need to have in order to be able to descend below decision altitude or MDA. So if your radio quits while you're flying in an IFR on an IFR flight plan, the first thing you want to do is make sure that you do whatever troubleshooting situations make sense for your airplane. Obviously, the first thing is always check the volume. Now, most of the time, you're just doing a flip-flop between one side of the comm radio and the other, so the volume should not be a problem. But every once in a while, in my flying across the country, I found that the next radio antenna that I'm talking to is much farther away than the one I was just talking to, and so maybe turning up the volume will allow me to be able to make sure that I can hear them from a much farther away distance. Always check the frequency to make sure that you have the right one dialed in. If you have two radios in your airplane, go to the other radio. Since most of us are flying with headsets now, also if the headset is your problem, make sure you know where your handheld microphone is and how to plug that into your airplane, and then how to turn the speaker on your airplane so you know exactly what you will be able to hear the IFR, any communication coming through the radio at that point. The first part of 91.185, letter B, talks about what do you do if you're VFR? If you're VFR or you attain VFR somewhere along your route, if you're flying IFR and you lose radios, you're supposed to remain VFR and land as soon as practicable. That doesn't mean put it down in a cornfield someplace. Find an airport that is suitable for you to land at, and probably someplace where you can probably at least try to get your radio fixed. The next section, 91.185C, talks all the way about what you do if you're in IFR conditions. So the first part, C1, talks about what route you're going to fly. So first, you're going to fly your assigned route. This is usually the route that you wrote down in the CRAFT clearance that you got from clearance delivery before you took off. The V, everybody uses this acronym Avenue F to remember all this stuff. The V in Avenue F stands for if you're on a vector. Now this is the one that's a little bit out of order of the other three, because the other three are sort of connected, but the vector is all by itself. If you're being vectored at the time that your radio quits, even if they said, expect on course in 10 minutes, you go back to your original assigned route, expected route, filed route, whichever you have left, at the point of radio failure. You don't have to maintain the vector for any longer than the point where you know that the radio is broken. As soon as if you're on a vector and you realize the radio is broken, turn immediately onto the course that you've been assigned. The E in Avenue F is expected. Usually that again is also in the craft portion, but it's something that you've been told to expect in a further clearance. And in this case, specifically about the route you're supposed to fly. And finally, if you don't have an assigned route, you have not been, or the assigned route has disappeared because you've reached the clearance limit, or you don't have an expected further clearance route, then fly what you filed. So the A, E, and F in Avenue F are the ones that you choose in that order. Like I said, the V for vector is all by itself. If you're on a vector, you just stop the heading that you're flying on the vector and go immediately to the assigned, expected, or filed route, whichever you have left. So then the next part, paragraph, section 2 of 91-185, paragraph C, talks about what altitudes you're going to fly. Everybody uses the acronym MEA to remind ourselves of this, and although that can cause a little bit of a problem because the first M is not for MEA, the M in MEA is for minimum altitude for IFR operations. That could be the MEA if you're flying on a Victor Airway or any sort of route. It also could be the minimum obstacle clearance altitude, MEA, minimum en route altitude, MOCA, minimum obstacle clearance altitude. If you're off route someplace, not on a Victor Airway, then you pick the minimum altitude for IFR operation could be the off route obstacle clearance altitude. Remember, the MEA is the, we'll be looking at a chart later, but the MEA is the altitude that gives you not only obstacle clearance, but nav aid reception along the entire route segment. The minimum obstacle clearance altitude gives you obstacle clearance, but you only get nav aid reception if you're within 22 nautical miles of the nav aid. And the off-route obstacle clearance altitude gives you the 1,000 or 2,000 foot altitude above the highest obstacle in that section, that longitude quadrangle that you're going to be flying in. And so the minimum altitude for IFR operations, not only the MEA, it could be the MOCA, could be the AROCA. The E in MEA stands for expected. If you're told to expect a different altitude in a further clearance. And then the A in MEA is your assigned altitude. Again, usually this is the one you're going to get from the craft clearance at the beginning of the flight. But of those three, minimum altitude for IFR operation, route to altitude you're told to expect in a further clearance, or your assigned altitude, you choose whichever altitude is the highest and fly that altitude. Like I tell my students, it's not MEF, it's not MEAF, like in the other one where we had the F at the end. Your filed altitude is not a choice in this situation. Only the minimum altitude for IFR operation, the altitude you're told to expect, or your assigned altitude, whichever is higher. The filed altitude is just something that that you're looking for, but if you don't hear that number over the radio, you fly whatever they tell you. And then the last thing about the regulation here is the part that people usually miss a little bit, especially on the check rides that I've been doing, because it doesn't have a handy dandy little acronym to go with it. So what do you do when you reach the clearance limit? So there's two paragraphs in there. Paragraph 3 talks about if the clearance limit that you've been given in the clearance, the last point in the clearance that you've been given is a place from which an approach starts, then you have to worry about if you've been received an expected further clearance time. If you've been given expected further clearance time, then, and that time is still in the future, you have to hold at that clearance limit point until that time has passed. If you have not been given an EFC, or the EFC is in the past, then you have to worry about your expected time of arrival, which is why you always write down the time you took off so that you know what the expected time of arrival is when you're flying on an IFR flight plan. If the expected time of arrival is still in the future, you hold at that clearance limit point until that time has passed, and then fly the approach. So if the clearance limit is the point from which an approach begins, then you have to worry about whether you've been given an EFC time, or if not, the expected time of arrival. Now, in the ATC people I've been talking to, they say if you ever find yourself in a calm out situation and it looks like you're going to get there early, if it's at all possible without falling out of the sky, please try to slow down so that the EFC or the ETA are already in the past. So all you can do when you get there is fly the approach. Because if you get over, like in the example I'm about to give, if you get over the top of Fargo and holding at the Fargo VOR, you've basically shut down the whole airport until you come in and try to land. Then the second part of the clearance limit is what happens if the clearance limit is not a point from which an approach begins. So then we still have EFC and ETA to worry about, but now it would be if you've been given an EFC for that clearance limit. If you've been given that time and that time is in the future, you must hold at the clearance limit which is a point from which an approach does not begin. If you haven't been given an EFC or that time is in the past, then you just blow right past that clearance limit and continue on to a point from which an approach begins. Then you have to worry about the ETA at the point from which an approach begins. If the ETA is still in the future, you have to hold at that point. If not, then you just fly the approach. So that's the regulation. Now let's take a look at the reality, how to apply the rule in a situation. So let's say you filed from Crystal Airport, you're going to fly to Gopher VOR, then fly Victor 2, the airway out to the Fargo VOR and land at Fargo Airport. And you filed at 4,000 feet. When you called up and asked for your clearance, the clearance you were given was cleared to the Weirda intersection, Whiskey India Romeo Delta Echo, via Gopher Victor 2. You always hate it when you don't hear the words as filed, because that means that they're going to send you someplace that you didn't file for. So in this case, they're clearing you to Weirda intersection via Gopher Victor 2. Climb and maintain 3,000 feet. Departure frequency is 126.5. Squawk 1234. Now let me move over to my other operation here. So going to my ForeFlight here, the scratch pad in ForeFlight has a CRAFT thing already set up for us. So we'll be able to use this to refer to as we figure out what we're going to do with this route that we've been given. So again, clear to Weird intersection via direct Gopher, Victor 2, climb and maintain 3,000 feet. Expect our departure frequency 126.5. Squawk 1234. So, going to the map, taking off out of Crystal Airport, going direct to Gopher, and then out Victor 2, which is the 297. So, if the weather is like it is right now at Crystal Airport, where it's 10 miles and clear, and we take off out of Crystal Airport. Well, maybe back up a second. And what the winds are doing, 130. So we're going to take off runway 14. So we're taking off runway 14 the Crystal Airport, which means we're taking off and going towards the southeast. We're cleared for takeoff by the tower. We get about 500 feet in the air. Tower goes, fly runway heading, expect on course in 10 minutes, contact departure. When we try to get a hold of departure, we don't hear anything. We've gone through the whole troubleshooting thing, and we still don't hear anything. So we realize that we're radio out. And so what do we do if the weather is 10-mile visibility and clear of clouds? And there's no clouds in the sky. So now we go back to the route, go back to the regulation. The first part of the rule is if you're VFR, you maintain VFR and land as soon as practical. So we're going to turn around and head back towards Crystal Airport, get ourselves set up for downwind to runway 14, and hope to see the correct kind of light gun signals when we get to the, when we get on final. Hopefully what we're hoping to see is a steady green light on final, which says that we're cleared to land. If we see steady red light on final, that means give way to other aircraft, continue circling is the official term, but basically what it means is do a go around, stay in the pattern. You'll probably get the green light on the next time around. But now let's assume that we have a 500-foot ceiling. And so when we take off, when we get to 500 feet, we're in the clouds. So now we're flying heading 140, runway heading, and we get the same clearance. Tower says, fly runway heading, expect on course in 10 minutes, contact departure. We try to get a hold of departure, and we don't hear anything. We do all the troubleshooting. We still don't hear anything. Now what are we going to do? So first we go to the route that we're going to fly, AVEF. So our assigned route is direct to Gopher, Victor 2. But we're on a vector right now, flying 140, flying runway heading. We don't have an expected further clearance. And we do have something that we filed going all the way to Fargo. So right at this moment, what we're going to do, since we're on a vector, is immediately turn direct to Gopher. So we're going to turn and go direct to Gopher because that's what that part of the rule says for flying the route. Now, what altitude are we going to fly? Since we're off route, so the altitudes are minimum altitude for IFR operation, altitude to expecting a further clearance, or the altitude that we were assigned, whichever is higher. So we were assigned 3,000 feet. We have not been given an expected further clearance altitude. The filed altitude of 4,000 feet doesn't work here. And now we got to figure out what's the minimum altitude for IFR operation where we are right now. So we were heading southeast away from Crystal Airport. Now we're turning around to go back to Gopher. We are not on any Victor Airways yet. So now we have to look on the approach plate on the en route chart here for the Aroka altitude. The Aroka altitude are those brown numbers that are in the latitude and longitude quadrangle. So for where we are right now, the off-route obstacle clearance altitude is 3,600 feet. Our assigned altitude is 3,000 feet. So at this point, we're going to climb up to 3,600 feet as we head direct towards Gopher. Then continuing on our route situation and altitude situation, when we get to Gopher, you got the big number out there. There we go. So when we get to Gopher, we're going to start on Victor 2, which is flying out to 297-degree radial away from Gopher. And once we get on the Victor 2 line, we got to make a choice again. We're on the route now. We're flying direct Gopher. Now we're on Victor 2, heading towards Weirdy intersection, wherever the heck that is. And now we got to figure out what altitude to fly. Now that we're on a route, our minimum altitude for IFR operation can either be the MEA or the MOCA. So right now, on this portion of the route, all we have is the MEA. If you notice up there in the upper left-hand corner there, we have the 3,400. And that is with the numbers without the star next to it is the minimum en route altitude, the MEA. So our MEA, our minimum altitude for IFR operation at this point, now that we're on Victor 2, is 3,400. We still don't have an expected altitude. Our assigned altitude is 3,000 feet. So once we get on to Victor 2, we're going to descend out of 3,600 feet and descend down to 3,400 feet. We're going to maintain our route on Victor 2 at 3,400 feet, going past all these intersections as we fly along here. And then we get to Alexandria VOR. Getting to the Alexandria VOR, we're going to continue on in Victor 2, but on the other side of that, in the upper left-hand corner of our screen there, now we have two choices of altitudes to continue on with Victor 2. The number on top, the 3,500, is the MEA. The star number underneath it, 3,000 feet, is the MOCA, the minimum obstacle clearance altitude, which gives us obstacle clearance altitude and nav aid reception within 22 nautical miles of the nav aid we just passed. In this case, Alexandria. So, and then our assigned altitude is still 3,000 feet. So, could we choose 3,000 feet to fly since both those numbers are exactly the same? The way I interpret the rule is you would want to go down to the MOCA if there's a reason for you to go down there. Just after you pass Alexandria, you look out the window and the tire is out of the clouds and you're in the clouds. And if you go down there from 3,400 feet down to 3,000 feet, you're going to get into VFR conditions. You can remain VFR and land as soon as practicable, just like the reg says. Then I would go down to 3,000 feet if it, with the situation that we have right now, where assigned altitude is only 3,000, so the numbers end up being the same. But if the ceiling in Alexandria is still 500 feet overcast, there's no reason to go down to 3,000 feet. You might as well just climb right on up to 3,500 feet because you're just going to continue on Victor 2 as we keep traveling to the northwest. Past Panic intersection, and then finally, right there in the bottom of the screen, Weirda intersection. Whiskey India Romeo Delta Echo. That is our clearance limit. We did not get expected further clearance after that. So, and if you look at all the approaches into Fargo Airport, Weirda is not on any of them. So it's not a point from which an approach begins. So now we have to go to the second part of that clearance limit rule. It says if your clearance limit is a point from which an approach does not begin, then if you've been given an EFC, you have to hold at Weirda until the EFC time. According in all the stuff that we've been talking about here in this scenario, we have not been given an EFC time for Weirda. So we don't have to hold at Weirda. We can just go right past Weirda. But now, what are we going to fly past Weirda? Because that's the end of that's our clearance limit. We don't have any more assigned route left of Avenue F, right? So we don't have an assigned route anymore. We had not been given an expected further clearance route at any time before the radios died. So now this is where you would use the filed route. So from Weirda, you're going to continue on Victor 2, go to the Fargo VOR, and then figure out what to do from there. So now then if we get to the Fargo VOR, now we have to work in this situation where our clearance limit was not a point from which an approach begins. Now we're at the Fargo VOR, that is a point from which an approach begins. Now we again have to make a choice. Looking at our ETA, is our ETA still in the future? Then we're going to have to hold at Fargo VOR. If the ETA is in the past, then we can figure out what approach we're going to fly and then fly that approach. In either situation, since you're on Victor 2, the way you would hold at either Weirda or Fargo in either situation here is just right along the route. Get to the point, make a right turn, because that's the standard turns in a holding pattern. and make 1 minute legs if you're below 14,000 feet. So now we're at Fargo. Now what are we going to do? So now first we have to take a look at what's the weather at Fargo. So KFAR, Hector International Airport in Fargo, North Dakota. So let's assume for right now that the weather is IFR at Fargo, but the winds are exactly like they are right now. Where wind. Isn't that interesting? So I had to pick a day where Fargo decides to stop giving out winds. Okay, so see what the task says. So where the task says for the time we're going to get there, the winds are 020 at 6 knots. So we go to the procedures here and look at the approaches into Fargo. The winds from 020, we're probably going to be landing on runway 36. And in this situation here, not knowing exactly what the weather is going to be like when we get there, because we don't have any way of getting AWOS or ASOS or ADIS or any of that type of information because the radios aren't working, I would pick the approach that gets us down as low as we possibly can. So in this situation here, I would pick the ILS to runway 36. Let me scoot this around a little bit so we can see it better on your screen there. So there we are. If we decide to do the ILS to runway 36, then now we're at the Fargo VOR, what are we going to do? Well, obviously we're going to take the 210 radial out of the Fargo VOR, go out to the 7 DME arc, or go out to 7 DME and arc back towards the localizer. After, and during all this time, setting up all the appropriate frequencies and everything that we need in order to be able to fly this approach. But what altitude are we going to fly after we get past Fargo? The 2,800 feet there is not part of the approach. The approach starts where the line becomes thick on the approach plate there. The thin line is not part of the approach. So now we still have to work with our altitudes that we have to worry about before. So the minimum altitude for IFR operation at this point from Fargo out to Day Ave is 2,800 feet, but we've been assigned 3,000 feet. So since our radios aren't working, at this point at Fargo going out to the 7 DME arc, we're going to fly at 3,000 feet. Once we get to Day Ave and turn onto the arc, then we can go down to 2,800 feet. Fly the arc around until we intercept the 356 degree on the localizer and go down here to the bottom, maintaining 2,800 feet till Abdi intersection, which is both the final approach fix for the localizer, the Maltese Cross there, and the ILS final approach fix, which is the lightning bolt symbol next to the 2,800 foot there. So at Abdi, we're going to start on down from 2,800 feet, after intersecting the glide slope, following that altitude all the way down to the straight-in ILS minimums of 1,099 feet. So we've been doing our very, very best to maintain the big plus on the gauge there, so that we're on localizer and on glide slope, and we're all the way down to 1,099 feet. Now what? So need to switch back here.
Can you go back 2 screens just to see the initial clearance, please? Yeah, right there.
There you go.
Okay, so 3,000 was our assigned altitude.
That's correct.
Thank you.
So now we're 1,099 feet at Fargo Airport. Now we have to figure out, can we land? Can we descend below our decision altitude or the MDA? So 91.175 is the regulation that talks about takeoff and landing in IFR situations. But the first part of the regulation talks about the landing part rather than the taking off part. So the first thing we have to realize is we must be continuously in a situation where using normal maneuvers and normal descent rates, we can descend on down to the runway. That's what the reg says. In the airline world, they have a different sort of term for this. They call it a stabilized approach. Some of the other aircraft companies like Cirrus loves to talk about making sure you're in a stabilized approach situation. But but I tend to lean more towards this because the airline definition of a stabilized approach is a lot different than what we normally fly. The airlines also have different rules they have to fly in if they aren't in a position to do a stabilized approach. Then they must and be able to land in the first third of the runway. Then they cannot land at that airport. Now, for us, for landing at a place like K.I. Sawyer up in Marquette, Michigan, that used to be a 2-mile long runway. Now it's only 9,000 feet, but it's still 2,000 feet of concrete, 2 miles worth of concrete. Used to be a B-52 base up there during the Cold War. So it's 9,000 feet. If you don't see the airport until right over the end of the runway, you can use a normal maneuver and a normal descent rate and still land on the runway with plenty of room to get stopped, depending on what kind of airplane you're flying. So you have to know your airplane to figure out what is normal maneuvers, normal descent rates, and the length of the runway that you can do. For those of us who are teaching and learning how to fly out of Crystal Airport, if you don't see the airport till you're right over the end of the runway, it's only 3,200 feet long. You're 500 feet in the air. Even for the best approach going into Crystal, you're not going to be able to use normal maneuvers and normal descent rates to get down to that runway. So it just depends on where you're going and what this means. But even though everybody remembers that the descent below decision altitude MDA, there's a whole list of stuff we got to remember. We're going to get to the list here in just a second. But there's 2 paragraphs before that. The first one is using normal maneuver. Got to be able to be in a spot where you can continuously descend down to the runway using normal maneuvers and normal descent rates. The second part of that, paragraph 2 in this section, talks about the visibility. You have to have the flight visibility prescribed in the approach. That does not mean the visibility in the weather report. That does not mean the visibility that the tower is telling you that it is. Flight visibility is the visibility that you can see outside the cockpit. Now, you have to look at your approach plate to figure out what the visibility needs to be. Obviously, if we're flying an ILS approach into Fargo, then the flight visibility needs to be a half mile because that's the visibility prescribed in the approach. But the tower may be calling a quarter mile, but if you can see a half mile, then you can continue on descending below decision altitude and MDA. And the final thing of 91.175, operation below decision altitude and MDA, is the whole list of stuff that you have to see. The first part of the list is if you see any one of these, you can descend all the way down to the runway. You have to see the runway. If you don't see the runway, if you see the runway lights, then that's fine too. If you don't see the runway lights, and if you see the runway markings, which is kind of hard to see, what's the difference between a runway and runway markings, but anyway, that's the way the reg says. If you see the runway lights, or the runway markings, then you can descend all the way down and land. The next one is the threshold. You see the threshold lights or the threshold markings, then you can descend all the way down to the runway. And this is the way I memorized it. If you see the touchdown zone lights or the touchdown zone markings, you can descend all the way down to the runway. Now, the tricky part about this is the touchdown zone doesn't exist unless it's painted on the runway. So the touchdown zone is basically, so when you're reading the reg, my list has 12 things. The regulation only has 11 things because the touchdown doesn't exist without the markings. But anyway, so the runway lights, runway markings, threshold lights, threshold markings, touchdown zone lights, touchdown zone markings. It just gets me into a little bit of a rhythm there, and that's how I memorize it in the first place. And I realize that the touchdown zone doesn't exist unless it's painted on the runway. If you see the very visual glide slope indicator, either the PAPI or the VASI for the runway that you're going to, you don't need to be able to see anything else. You just keep the on glide path indication and descend on down to the runway. You have the runway and identifier lights in sight. You don't need to see anything else. You can use the runway and identifier lights to descend down to the runway. So the next part is talking about the approach lights, and that's where people always get confused because it's written like a lawyer in the regulation. So if you see the approach lights, you can descend down to the runway if you see the red terminating bars on the approach light system or the red side bars on the approach lighting system. There's two separate types of approach lights that have that. We'll talk about what that is here in just a little bit. But if you don't see any red lights in the approach light system that you're seeing through the fog, then the rule is you can only go down to 100 feet above touchdown zone elevation. So if I'm going into an airport on an ILS approach and I know I'm going to be going down to minimums, I'll memorize two numbers. One of them is the decision altitude that I need to look up in the first place to see if I see any of these things. And then the second number I memorize is 100 feet above touchdown zone elevation, because if I get down there and all I see is white approach lights, then I can keep going down until I see one other thing on this list, and then I can land. If all I see is approach lights and nothing else, I got to go missed approach. So let's go back to our Fargo situation here and see how we apply this rule to the situation. So here we are coming into runway 36 at Fargo Airport. So we see approach lighting systems labeled as an A5. Stand by a second. I'll refine my situation here. A5, according to the explanation in the front of the approach plate book, is a medium intensity approach lighting system with runway alignment indicator lights, nicknamed Mauser. Well, what do the lights look like? Well, they look the same things as Seltzer. So if we go up here to the Seltzer explanation, all the lights in the approach lighting system are white. The green lights you're seeing in that picture right there are the threshold lights. So we got sequence flashing lights, we got white lights. So if it's an A5 on our approach plate, we're never going to see red lights. So we can know right away that if all we see is approach lights, the only thing we can do according to the rule is descend down to 100 feet above touchdown zone elevation. And then hopefully you see one more thing on that list. They move over just a little bit. The one with the red sidebars here that I just put on the middle of the screen is an ALSF2 system. On the approach plate itself, it has a circle with an A in it. And right below that is the ALSF1 system, which has the A1 designation, and this is the one with the red terminating bars. So if you're flying into an airport and you look down at your approach plate and you see any other A in the circle except for A or A1, then it's only going to be a white approach lighting system, and you can be preset in your mind that if you see approach lights only, you're going to be going down to 100 feet above touchdown zone elevation. The ALSF1 and the ALSF2, the A and the A1 on the approach plate are the only ones with the red sidebars or the red terminating bars. And so then you would be, if you only see white lights, but you know that you're going to have this, if you get in a little bit closer, then you see the red terminating bars or the red sidebars, then you can continue all the way down to the runway. You just put your airplane right between the red sidebars or right in the middle of all those red terminating bars and keep going until you see the runway. Just keep on coming down. The only airports that have ALSF1 or ALSF2 is the big airports. I mean, I think the only one in our area here in the Twin Cities in Minnesota is Minneapolis. They might have these up at Duluth. I haven't looked at there in a while. But most of the airports that I fly into, as far as training airports are concerned, they have the A5 Mauser system, so we know that it's always going to be white lights. And while we're on this page here, let me move up to this upper corner here. If you're looking at the approach, airport diagram in on the approach plate, and you see dots down the middle of the runway, that means that in addition to the side lights on the runway, they also have runway center line lights. And then if they have the lights listed on the side there, they also have touchdown zone lighting listed, or touchdown zone lighting. Again, this is usually for big airports, just because in order to get runway center line lights and touchdown zone lights on the runway itself, they have to dig into the runway. I'll usually probably put this in as they're reading the runway in the first place, so they can put in the lights, then put in the concrete, and so that they'll always be there. So going back to our approach plate here, we notice that there are no dots down the middle of the runway. There's no white spots with the black dots anywhere near the runway. So we don't have runway center line lights. We don't have touchdown zone lights, but we do have the approach lighting system here. And at this point, all we're going to see is white lights. And so then in this situation here, going up to the top, touchdown zone elevation at this airport's 899. So if all we see is white approach lights, we're going to descend down to 999 feet. So which visual glide slope indicator are we going to have at this airport? Is going to be a PAPI. That's the 4 dots all in a row. For on glide path like we're supposed to be on the glide path here, then we're going to be close, but not quite. The VGSI and the ILS glide path are not coincident. So we may or may not see 2 whites and 2 reds, but if we see the PAPI lights of any type, we can continue all the way down to the runway. So at this airport, the runway is obviously that. The runway markings will be the number 36. The runway lights will be the lights down the side of the runway. At this airport here, they'll start out as white lights, and then 2,000 feet before the end, they'll turn amber. Since the runway lights down the side change from white to amber. Stand by. The runway lights will change from white to amber the last 2,000 feet to the last half, whichever is shorter. So in this situation here, we're going to go to, the lights will change from white to amber the last 2,000 feet of the runway. The touchdown zone we talked about, the threshold, is going to be green lights at the very end of the runway. The threshold markings at an ILS runway usually have the piano key looking stripes painted on the runway before you get to before they paint the runway number on the runway itself. So since this runway is 150 feet wide, we're going to see 6 stripes either side of center line because the number of stripes that they paint on there is the width of the runway divided by 25. So it'll be 6 stripes either side of center line on runway 36 for our threshold marking. Since we have approach lights into this runway, we won't have runway end identifier lights. The only runway with runway end identifier lights is runway 9 and 27, because the approach lights and runway end identifier lights are mutually exclusive. They won't put both of them on the same runway. So we won't see reels on this situation. All we'll see is the approach lights. So if we get down to 1,099 and all we see is the approach lights, then we're going to go down to 999 feet and hope we're going to see at least the runway markings, the threshold markings, the touchdown zone markings, the PAPI lights. There was one time I was coming into Flying Cloud Airport. They said that it was a 200-foot ceiling, 4 miles visibility. So I figured I'd be able to get down to fly the ILS, runway 10 right, get down there and be able to see the entire airport because it's 4 miles visibility. I got down to decision altitude on the glide slope. I looked up and all I saw was approach lights. So just like I always did myself, memorize the 2 numbers. I'm back inside, keeping my descent rate going, keeping the glide slope centered, keeping the localizer centered, going down to 100 feet above touchdown zone elevation. I looked up and all I saw besides approach lights was white, white, red, red of the PAPI lights. And so I just stayed on the white, white, red, red with my head outside the cockpit. And like at the last second, the runway came out of the mist, like Brigadoon, for those of you who are musical fans. Anyway, so you can put PAPIs on that list. If you see the PAPIs, the visual glide slope indicator, then you can go all the way down to the runway. The nice thing about the picture is it tells you that the PAPIs are on, in this case here, are on the right side of the runway, so you're going to be looking for the runway to the left of that. All these things would be stuff that you would be looking at the entire time you're flying, not talking to anybody, with your radios out all the way into Fargo. But now we're at 1,099 feet. So backing up in our approach here, we're down. We just now got to 1,099 feet. We look up and we don't see anything. So now what do we do? Well, first off, fly the missed approach procedure. Climb straight ahead to 2,500 feet and go out to AA, whatever that is. So let's go back up to the verbiage up at the top here. Climb the 2,500 feet, direct a Kenny locator outer marker and hold. For in a DME airplane, we could go out to Gorgie if we wanted, but so we go out to Kenny, do a parallel entry, but now what? If our radios still aren't working, what do we do? The answer is go to your alternate. This is why if you have to declare an alternate at an airport, you want to make sure that the weather at that alternate is good enough for you to be able to do stuff, be able to go in there and land. So the regulation says if the alternate has an approach, if it's a non-precision approach, the weather at the time you arrive there must be 802. If it has a precision approach, the weather at the time that you arrive there can be as low as 602. You can, according to the regulations, pick an airport that doesn't have an approach to it, but then you must be able to descend in VFR conditions from the nearest MEA to descend down and land. So in that situation, me personally, I probably would never pick an alternate where it doesn't have an approach. But you want to make sure, and maybe even a little bit better than 802 or 602 for the alternate that you want to get to. Because if you get to this point, your radio's not working and you have to go miss approach for whatever reason, whether it was your fault or the weather's fault, your only choice is to go and fly to your alternate. So when radio's working, everything's negotiable. You can tell tower, tell approach you want to try, get vectors for final again. You want to go fly to Alexandria. You want to You don't want to go to the alternate you have on your list there. You want to go to a different airport. If the radio is working, everything's negotiable. But if the radio is not working, you have to go to the alternate that you put on your flight plan when you filed it with the 1-800 Weather Brief folks. So now, back to here. Now, wait a minute, before we do this. So I'm just looking at the chat stuff. Yes, unable, do not accept the clearance that does not have, without the destination as a clearance limit. That is always an option. This is just a scenario that I use to be able to ask the students that are on their instrument and the courses to make sure that they know the rules and stuff. And somebody else says, always underestimate your estimated en route time so that you don't have to worry about holding. And that's always something that's very good to do. Because so for an IFR approach, if it says it's going to take you 2 hours to get there, tell them you're going to get there in an hour and a half, so that if you do lose your radios, you can just continue right on into and fly the approach. And somebody put a thing of the pictures of the approach light systems as we're going there. That was good. Any other questions at this point before I continue on?
A couple of comments, if I could.
Yes.
A couple brief comments.
Go ahead.
Okay, you mentioned, well, let me back up one. In our clearance that was issued to us, it was maintain 3,000. There was no expect 4,000 10 minutes after departure, nothing like that.
That's correct.
Right? Okay. So that's something else I would refuse to accept as well, because that altitude is wrong for our direction of flight.
Yeah,
and
I know.
it's also below, MEA, and that way, if we get our 4,000, we don't have to, problem solve or try to figure out in our mind, what's the highest of last assigned, told to expect, all that nonsense.
Yeah, that's exactly right. Yeah,
Okay.
If you file for 4 because that's what the MEA tells you you're supposed to do, and 3,000 feet's too low, you're right. Before you even leave the ground, while you're still talking on the radio, you're going to say, I need a higher altitude before I leave here. That's exactly right.
That's right.
And
Now,
this is just a scenario I use to get people thinking about how that rule applies to a certain situation.
And that's good, because that means that we are making that application without the pressure of flight. We're doing it on the ground before we depart, just as you
Exactly.
said. You did say one thing I disagree with, though. Can you go back to the instrument approach procedure? The ILS 36 into Fargo.
Okay, hang on a second.
And zoom in over the VOR on the plan view. All right, good, right there. That's fine. That's good, right there. You can actually zoom out a click or two. Okay, now you said that if we're at 3,000 and our clearance limit is the VOR, then we have to, or that's where we're going. You said we have to depart the VOR at 3,000, not 2,800, because that's not where the approach begins.
That's correct.
Okay, I realize, I agree with you that DAEV is noted as IAF, initial approach fix, and the VOR is not. However, since we have a published transition from the VOR along that 210 degree radial, as defined by 2,800 feet and 7 miles, I believe that is part of the approach procedure, and that's where the approach begins for transition purposes. So let's say our assigned altitude was 10,000 feet. how are we going to get from 10 down to 2,800? We're going to have to spin in a hold somewhere. So I see nothing wrong with departing the VOR at 2,800 feet if that's where we were burning time until our estimated time of arrival is adjusted and so on and so forth.
Yeah.
Which can all be avoided by underestimating our EET, as we talked about earlier.
Yeah. No, that makes sense. That makes sense.
Notice that the 210 radial between the VOR and DAEV is heavy, whereas the extension of the 210 radial southwest of DAEV is lighter. So 210 between DAEV and the VOR is a transition, whereas radial 210 southwest of DAEV is just a crossing radial.
Yeah, that makes sense. Yeah, okay, I see your point.
Okay. But a lot of this, because of the way this rule was written, and remember it was written many years ago, before technology improved the way it has today and the reliability of our avionics and so forth. So the likelihood of having a two-way radial failure is going to be a lot worse if it actually happens. It'll be more of an electrical system failure than the failure of the radio itself. So the way to shortcut all of the obstacles that are thrown at us in that regulation is, as we've already discussed, underestimate your EET. There's nothing wrong with doing that. And also don't accept anything goofy in your clearance just because that's the way it's delivered to you. You have every right to negotiate something that works for you as a pilot in command on the ground before you depart, and clearance delivery is obligated to work with you on that.
That's correct. So
thank you.
No problem. So now we're at the hour right now. If anybody needs to log off, that's fine. We'll just talk about, let me take a quick little short break here, then we'll talk about what if the worst happens and you do have that total electrical failure. Now what are you going to do? We'll talk about that next. I'll be right back.
I see a question from John here. Is it necessary to file a report with FAA following successful completion of a failed radio flight? Like if you end up at some untowered field somewhere? Is that what you're referring to? John Crack, do you have a microphone you can unmute?
Okay, can you hear me?
Loud and clear.
Yeah, I didn't have any specific destination airport in mind, but this is in some sense, this is an incident. And I was just wondering, do we say we're going into a non-towered airport or even a towered airport? Do we have to file anything with any report with the FAA describing what happened and what we did, or is everything cool once we get landed and advise the FAA that we're landed at a non-towered airport, or they know it if we're at a towered airport?
Yeah, in that situation, you're going to have to, if you're getting at the ground, going on the ground at a non-towered airport, then it's just like when you're doing, flying VFR, you're going to have to get on the phone to 1-800 weather brief and tell them that you're on the ground.
Right, close the flight plan.
Yep. Now, whether you have to do any reporting after that or not, this is not a reportable incident as far as the regulations are concerned, but the, ATC may want to talk to you about, about something, but as far as reporting it to the FAA, I don't think that would have to happen.
Okay, thanks.
No problem.
I'd recommend that if you're doing this under IFR and you're talking to Leidos, to have them relay, say, to center or approach that you are safely on the ground. Wait on hold until flight service tells you that they've confirmed that your message has been received by that appropriate facility. Don't just say to flight service, just tell them I'm on the, I'm on the ground and hang up, because that could get lost in the shuffle.
Okay.
And that way, you know that you've done everything you need to do because flight service has told you that you've done it. It's also on tape if needed, and so forth.
Thank you.
So now, what happens if, so the next question I ask the students then is, what happens if you take off from Crystal, you get into the clouds, and you hear it in the headset, and you look over there, and the whole comm panel has disappeared. You have no comm 1, no comm 2, no nav 1, no nav 2, GPS is gone, no transponder. Everything's been, the whole thing is shut down. So you now have no communication. You also have no navigation information either. So at this point, you're basically, I read somewhere, they can't regulate everything. So sometimes you just have to do the best that you can.
Which is, in this scenario?
Use your best judgment. We know what altitude you're going to fly. One thought is pick something above the Aroka, but then fly a VFR altitude. Because if you're in the clouds, except for people climbing and descending, you should not be at the same, you should not be at an altitude. Nobody should be at the VFR altitude because everybody's even thousands or odd thousands depending on which direction they're flying. So if you put yourself at a VFR altitude, you'll be 500 feet away from all the other people. You still got to believe in the big sky theory and make sure to believe that nobody's going to hit you while they're climbing or descending. But that's a thought, not a requirement. What heading you're going to fly? Way back last century, when I learned how to fly IFR, one of the things we always talked about when we were talking to the flight service station and on the phone was as we were filing an IFR flight plan, where's the nearest VFR? So we know which way to point our airplane in this situation to try to get to a VFR point, to get the airplane down to land. When I was teaching in North Carolina, I always tell people to just head east till you figure out you're out over the ocean, and then start a nice slow descent. You break out of the clouds, go back to the coast and land on an airplane out of the coast. If the altimeter starts to read 0, pull the power back and start flaring because you're about to hit the water. And then in Tennessee, I said, head west, because Tennessee is shaped with the Appalachian Mountains on the east side and the Mississippi River on the west side. If you head west, you got a better chance of descending down and not hitting anything while you're trying to get yourself out of the clouds. Here in Minnesota, here in the Twin Cities, we're kind of in the bottom of a bowl. Everything else around us seems to be higher. So if this happened out of Crystal, I'd probably head east or north to stay away from the big airport down there, and try to do my best to find a way out of the clouds in over all those farm fields that are west and north of the Crystal Airport. But now, that was all the stuff that we talked about back in the days when we only had the VOR, the ILS, and but now I got a tablet sitting in front of me, and I have mine hooked up to the phone system so that and there's a GPS chip in it that will continue to work even if the GPS input from the ADS-B in stops working. I'll still be able to figure out where I am. If I downloaded the weather before I left, I'll be able to tell where the VFR is by tapping the appropriate stuff on the tablet and trying to fly a direction to get myself down. Worst case scenario is I spent a little bit extra money on the ForeFlight, and I have the airplane that flies along on the approach plate too. I could use that to fly an approach into another airport and try to get myself out of the clouds that way. Probably wouldn't come back into Crystal. I'd probably go someplace that I know it's not quite as busy, like Princeton or Cambridge or something like that. But so this is one of those things where we could talk about. There's lots of different ways of doing this because there's nothing written down anywhere. This one is all has to do with what's, what do you think is best at the time, and what do you have available to you inside the cockpit?
There's also one other thing we have to do that immediately in that situation that sets the pace for all our future decisions. And it's really simple, and it's easy to overlook. Any idea what that would be?
Fly the airplane?
Well, beyond that, we don't want to stall and turn it upside down, of course, but
Right.
there's one action we have to do out of the ordinary that we don't even think about, but it really ties into every future decision we're going to make. And it's really simple. Note the time, because we know where we are,
Right.
in the vicinity of the airport we departed. If we're going to head north out of Crystal, head west out of Crystal to put Bravo behind us, then we can judge our distance based on time.
That's correct.
I like what you said about flying out over the ocean, although I wouldn't want to, end up in Africa before I decide to turn around.
Oh yeah, that's what. I forgot to mention that you fly it over. You figure out how long it's going to take you to get out over the ocean in North Carolina, so that you're not too far out, so that you be able to turn around and come back. Any other questions, comments, concerns?
Just a comment. Back in the dark distant past, I've been flying since 1957. Back in the dark ages, when technology started to come forward, that was one of the big uses of the backup handheld radio. That was a big improvement.
Mm-hmm.
And if everything failed, if you had that, back in those days, you could find airports where they did assisted IFR approaches to you, telling you exactly what to do, which direction, gave you a heading, your glide, bringing you down the glide slope. You just sat and listened and followed instructions. So that was the days before, it worked, that's for sure.
Yeah.
Does Duluth still provide PAR?
Yeah, it originally was a spin-off in Australia and in England from the military. Used it, of course.
Yeah, I don't think Duluth has a PAR anymore, but they will give you. But I'm pretty sure they probably have an ASR up there. I mean, not published, but they got F-16s flying in there. They got to have something like that. Rochester has an ASR approach.
I mean, the big benefit these days is, as you look at complete loss of everything, is, hey, iPhone with ForeFlight on it.
Yep.
That's assuming we're all still pretty good at basic panel steam gauges.
You would hope so.
Big assumption.
Right. When you board up on them and convert to flat screen, it's certainly easier than going the other way, learning on flat screen and wondering what these round things are.
Yep. Any other questions? So thank you for attending today.
Actually, yeah, I do have one
Okay.
more for you. And it's a matter of opinion, really. I wanted to ask, so let's say we fly this routing that we're given, and hopefully our clearance limit is going to be beyond weirdy, but if it isn't, do you really recommend flying to the Fargo VOR and then flying outbound on an ARC to join the final just because it's published that way? Wouldn't it be less of an intrusion, and seeing how, assuming the transponder is still working, you're being watched on radar, wouldn't it be less of an intrusion to just simply join final at the intermediate fix WOLUV I see out there, which is where the ARC joins the final? Just join the final and descend on and land.
Yeah, but the whole reason for the regulation is just so that you're predictable. But you're right. By the time you get that close, there isn't going to be anybody else in your way. So if all of a sudden you just, as you're on your way to Fargo, you turn and intercepted the localizer, they'd probably be able to react. But the main idea for for the entire part of the regulation, what altitude do you fly, what route do you fly, when do you leave the clearance limit, is so that you know what you're doing, they know what you're doing, so they'll keep everybody out of your way while you're doing it.
Okay.
But you're right, at that point, you're that close to Fargo, there's probably gonna be nobody between you and the airport. So that if all of a sudden you just turned on the localizer, they'd probably be able to react.
I mean, just a thought here. I mean, the regs were written, many years ago when communications wasn't as reliable as it is today. And, it could be a daily occurrence of people losing complete communications. Today, if looking at the route that you ran over with today, by the time you're getting up to Fargo, ATC is well aware that your communications are toast, and you're probably the only one around. So I don't think they'd probably burn you at the stake if you, did a direct approach under the ILS there. It's bottom line is to try and get you down safely. It wouldn't be according to the regs, but hopefully they'll give you a little bit of a leeway and avoid unnecessary, maneuvers in flight. I guess that's the way I'd look at it.
Yeah.
I would think the 91
we flew an ARC, right?
Yeah, stay away from the ARC if you can, that's for sure.
I would think the 91.3B deviate in an emergency allows you to, would be something that I could argue if I had to.
Right.
That this is why I don't want to go to the VOR, hold, reverse course, try to, manage all these moving parts when I could simply just turn final and descend on the profile and land.
Yeah, I think you get leeway. I really liked the throw up because I mean this, God forbid, hopefully this never happens to any of us. It's which you look at it and as long as you've been doing everything else that you laid out, with the altitudes you selected and et cetera, just to shortcut the approach a little, just to less time in the air and more of an easy approach. I would think the ATC or the FA would be fairly generous with you on that aspect.
I see John put a question in there about the COM failure code at 7600.
Yeah, that's a goodie.
Although I don't believe the AIM says, I have to check this. I haven't looked at it in a while. Does the AIM still say squawk 7700 for 1 minute and 7600 for 15?
No,
or is that ancient
was
history?
back in the days when you had to squawk 7,700 feet to get all the alarms, bells and whistles to go off in ATC. They've fixed that. So now if you squawk any of the three 7,000 codes, it'll set off the bells and whistles.
Okay.
So the next seminars that we have coming out of Thunderbird are at the Great Minnesota Aviation Gathering at the Buffalo Airport, Friday and Saturday, May 21st and 22nd. Paul Block, our Director of Maintenance, is going to be doing a presentation at 9 a.m. on the Friday, talking about cleaning out the cobwebs, getting your airplane out of the hangar, ready for flight for the good weather. I will follow him immediately after that at 10 o'clock with a introduction to ForeFlight, but they only give me 45 minutes to do that. So the rest of the day, I will be at the Thunderbird Academy College booth. So if anybody has questions about any of the stuff we talk about here or the ForeFlight stuff, you can come by there and talk to me about that. Paul's also bringing a little show and tell, a big show and tell. And so we can talk to people about what's required for the PA-28 wing AD. And my next online seminar will be on June 12th, second Saturday in the month at 1 p.m. I'll do an expanded 2-hour version of an intro to ForeFlight. Just go to fasafety.gov to sign up.
What date was that again?
June 12th, that'll be Saturday.
Thank you. You're going to take care of the wings thing after we're all closed out here, presumably.
Yeah. The guy who runs our Zoom stuff sends me a list, and I send it into put it into the system. I'll get it done sometime next week.
Well, thank you for doing this. It's been a very clear recap of things that we don't think about because hopefully we never run into them.
That's right. And that's all I got. Unless anybody else has any questions.
Have a good what's left of the weekend. Mother's Day
Righty.
tomorrow. Mother's Day tomorrow, remember.
Happy Mother's Day for everybody. That's correct.
Take care.
See ya.
Thank you. Thanks.
You're
Take care.
welcome.
Bye, Fred.
Bye-bye.
Bye.